Hello everyone, let's see this question. Components along and perpendicular to a position vector are known as radial and transverse components respectively. A particle is projected horizontally from top of a tower. Assume acceleration due to gravity to be uniform and the origin of coordinate system at the point of projection. So in this case, which of the following options will match? We have to think. So let's first imagine the situation. So particle is projected horizontally from the top of a tower. So it will be going in a parabolic path like this. Okay. Now, uh, let's see the radial component of velocity. So having, if we are joining this with the radius vector here, okay, so the velocity, the acceleration is downward this way, g vector, and the velocity is along this direction, right, along the tangent. Now the radial component of velocity will be the velocity component which is along r, right? So it will be this component of velocity which is along r. So what will happen to that? You can see g has a positive component in that direction. That means that component will increase. Always it will increase. So for A, it should be P. Then the transverse component of velocity. Transverse component will be the perpendicular one, perpendicular to R. So when you do perpendicular to R, what is going to happen to that? So this is the transverse component. Now for the transverse component also, what you can see, that it will always be making some acute angle, right? So for that also, it will always have a acceleration will always have a positive component in that direction. So for B also it should be P. Okay. Then radial component of acceleration. So here the radial component of acceleration will be what? If this angle is theta, then the radial component of acceleration will be g cos theta. And what is happening to theta? As it is going down, what will happen to this theta? This theta will keep on changing. So here right now, this theta with the radial direction, it is this much. Now at a lower position, what will happen? It will change and it will become in fact smaller. So what can you say about the radial component of acceleration? That will also always increase, right? And then finally transverse component of acceleration. So transverse component would be the component in this direction, and that would be how much? It would be g sine theta. So what would happen to that? So as theta decreases, theta is maximum at top, it is 90 degree, and as it is going down, theta is decreasing, so that will also decrease, right? So it should always decrease. That is, for D, what we should get? We should get Q. Okay.